So the recording has started. Again, welcome everybody. We are thrilled to have you this evening, and it's wonderful when we have all of these educators coming above and beyond what they do during the day and meeting with us. A special shout out to Philip from the Microbit Foundation. It is actually 12 p.m. or a.m. rather in
it's Friday already. It's
Friday, right? That's right. It's like the college days, right? Who love pub night on Thursday night? Anyways, we're thrilled to have Philip from the Microbit Foundation and Tanya Parker from Code.org and Lisa Floyd from Fairchance Learning this evening to talk about Microbit and what we're doing in Canada to support coding, computational thinking, and just plain awesomeness when it comes to invention and creativity. So thrilled that you've taken this time to join us. And in terms of what will happen over the next hour and a bit is that we're going to hear from Code.org and the wonderful organization that they are and the mission that they are on, and then Microbit Foundation and what Philip and his team have been up to in terms of supporting the coding, computational thinking, invention, and creativity across the globe. And then in terms of what we're doing in Canada, Lisa will try and get you started and revved up with some ideas about how to take your microbit to the next level and integrate it into your teaching and learning in your Canadian classrooms. So without further ado, I'm going to pass it over to Tanya. Tanya's up first. So Tanya, if you want to take your mic off mute there and load up your slides, and we'll get going. Now, just while Tanya is getting all of this loaded up, we will let you know that there's a chat window that Tanya, Philip, Lisa, and myself will be interacting with. So if you have questions, please feel free to pose them there. Otherwise, share your learnings on #FCLEDU on Twitter, and we will continue this conversation as we go along. So over to you, Tanya.
Thanks. Can everyone hear me all right?
Yes.
I can. All right. So I am a technical product manager at Code.org. I started out as a front-end developer working on our international efforts, and that's how I ended up working with Philip. We definitely create K-12 curriculum, computer science curriculum that we are focused on working on school districts in the U.S., but also sharing that more broadly for free for any teacher worldwide. What I wanted to talk about was Code.org. A lot of people's impressions of Code.org because of our name is that we promote just coding, but actually what we are trying to do is have schools teach computer science and get access to computer science to as many students as possible. We want to increase participation by women and underrepresented minorities since they often don't have the opportunities to learn computer science. The world is quickly changing. Technology is becoming vastly more and more important to learn, and parents are recognizing the need for teaching computer science. Yet lots of our schools, actually I think I should update this graphic, I think maybe it's a little better now, but a lot of our schools, particularly in the U.S., still do not teach computer science. So we're working on getting more schools interested by doing a few things. One, it's just showing how computer science is not about learning technology. That is one of the misconceptions. Technology changes very quickly. The language that's popular now may be out in 2 years, 10 years, and those classes that focus just on a particular technology will be quickly outdated. But really, computer science is about core concepts like logic, problem solving, creativity. Any problem that computer science is trying to solve can be broken down into smaller parts, and it's not focused on how the technology does it, but how you are solving the problem and writing the code if you need to write the code. But one way to show that that computer science isn't just about coding is actually, the first computer was invented in 1943, but Ada Lovelace is credited with writing the first computer program back in 1843, way before technology was even supported for that kind of thing, because she wrote the first algorithm. And we also like to stress that computer science is not vocational, it is foundational. Just like biology, mathematics, reading, it's super important to learn about computer science because it affects so many parts of our lives. And we are trying to get it to be something that's given as a core class, whether it's starting to count as a graduation requirement for high school, but starting very early on from elementary, primary school, having students start with computer science as a core class. And this is because our world is changing so quickly, and there are so many jobs that are available for people who are involved in technology. It's not just California, it's not just software engineers, but every industry from farming to fashion to medicine uses technology in some way, and someone with a technical background, even if they're not a software engineer, can get many more opportunities in their career by having that kind of background. An interesting statistic I wanted to share is that we stress often STEM, science, technology, and math, engineering and math, but really many of the jobs, the majority of the jobs are computer science specifically that they're looking for. So we really want to try and stress for students to look more into computer science and having exposure to computer science topics early on. And which brings me to the Hour of Code. That is Code.org's big push in the Computer Science Education Week. It's the first week of December. Code.org really works with hundreds of partners, including Microbit, Fair Chance Learning. We are, in any way, shape, or form, trying to get everyone a chance to learn an introduction to computer science. So there are hundreds of activities to choose from. You can do something online through Code.org, through any of our partners. There are unplugged activities or activities that you can do without any computers or technology, of course, because it, again, focuses on the concepts and not the technology. And it's so easy to get involved internationally because of the wide variety of activities that you could do. And we've reached millions, hundreds of millions of hours of code served over the past 4 years. So this partnership with Fair Chance Learning and Microbit was a natural step because we would love for teachers to use more robotics and show how cool robotics can be and hardware can be for the Hour of Code. And if you are on Twitter, please let us know, how will you use your microbit for your next Hour of Code? Use hashtag FCLEDU and hashtag Hour of Code.
Thanks, Tanya. When you were talking about your partnership, Code.org's partnership with Microbit and Fair Chance Learning, I'm not sure. Well, I am sure because the video and the microphone was off, but I was going, ah! We're so excited. Lisa will share that excitement as well. But next, we've invited Phil Meitner. Am I saying it right, Philip?
That's pretty good. Yeah, thanks, thanks, Martha.
No problem. So we're going to invite Philip to share about the Microbit Foundation, and I'm going to walk him through his slides there. So I'm just sharing my desktop right now. While we load that, Philip, you'll confirm that you can see your piece, and we'll continue on the journey. And again, a big thank you to you for taking the time on a Friday early morning to be with us.
No, it's a pleasure. And you've, I was going to say you've jumped to my last slide, so I can no, well, it's an absolute pleasure. Thanks for inviting me, Martha, and hello, Canada. My name's Philip, yes, I'm with the Microbit Education Foundation, and I don't want to speak for too long because I know that Martha and Lisa have got a really fantastic program planned for you guys, and the longer I talk, the less coding you're going to get with the Microbit. So I'll try and be quick, but I do want to just give you a little bit of background as to what this Microbit thing really is and why we're doing it. So if we just jump to the second slide, thanks, Martha. The challenge that the BBC, who effectively invented the Microbit back in 2012, the challenge that they perceived was that the education system in the UK back then wasn't preparing the youth for the uncertain job markets of the future. To express that differently, there's a gap between the requirements for IT professionals in the job market and the number of IT professionals that are being produced. So whichever way you look at it, there's an issue, a problem. And the BBC, as part of their remit, they don't just make fantastic TV programs, they also produce educational materials for the UK youth. And so they set about trying to find a solution to this problem. How do we educate children into computational thinking, the sorts of things that Tanya was just discussing? And moving on to the next slide, the solution that they came up with on slide 3 is the BBC Microbit. Now, to jump from 2012 to 2016, 4 years, and just say, well, the BBC came up with a microbit, is simplifying things quite a lot, but obviously we don't have a lot of time. So the BBC looked at all the different ways that they might address these challenges, and the BBC Microbit was their solution. I think everyone on the call has one. I'm not going to introduce it. You'll get to experience it later if you haven't seen one already. The BBC in 2016 gave away 1 million of these devices to year 7 school children in the UK. These are school children just starting their high school journey. And at the end of that program, when they've given away those 1 million, they, along with a number of other organizations that you'll be seeing on screen, set up the Microbit Education Foundation, which is a not-for-profit foundation. And our remit is to bring Microbit to the globe, bring it around the world, and get kids coding. I'll mention the mission statement in a little bit. Oh, well, let's jump let's jump to that slide straight away. Look, the vision of Microbit in general, but also the vision that the foundation has adopted from the BBC, is that in the future every child will be an inventor. But I think the reality is, every child is an inventor, and you've only got to see your own kid when you buy them a present and you give them the cardboard box and all the fantastic and amazing things that they'll invent and create with that cardboard box. And that creativity, that inventiveness is something that, that children have and that we need to nurture, and we need to nurture it through the education system. And I'm not sure about Canada, but I don't know that maybe in the UK it's being nurtured as much as it should in the IT sphere in particular. So just moving on to the next slide, the goal of the Microbit Foundation is to reach 100 million children, parents, carers, educators and teachers around the globe with our platform. And that's a very ambitious target. Now just moving on to the next slide. We're getting there, slowly but surely. So you can now buy microbits in almost just over 35 countries, and in Canada shortly. The website's available. Our website's available in 13 different languages. We're already having national rollouts, not only in the United Kingdom, but in Iceland, Croatia, Singapore, and a few other countries, which we'll be announcing shortly. There's a lot of resellers on our books, but what's most exciting about Microbit is our ecosystem. And our ecosystem consists of organizations, individuals, foundations, charities, people who adopt Microbit and go out there and do work with Microbit in the communities. And this is a very long way of me really wanting to give a very big thank you to Fair Chance Learning and also to Code.org for taking Microbit on and working with it and believing in it and championing it, putting resources behind it and putting effort behind it. And it's organizations like that around the world that are adopting Microbit and working with it that is helping us to reach towards our goal and make Microbit the success that it can be. And everyone can be part of this ecosystem. You don't have to have a large training organization like Fair Chance Learning. You can be an individual and you can go out and do workshops at your local library or code clubs with your children's Girl Guides group, anything like that. So our ecosystem is what makes us strong. And our ecosystem doesn't just include individuals and groups. It also includes our website, which has got a fantastic option of editors, which you'll see later. It includes a huge amount of learning materials that have been generated not just for the UK, but increasingly of relevance in other countries around the world. And again, great thanks to Martha and Fairchance Learning for the work and help they're giving us there. But it also involves all the communities. There's a lot of very vibrant communities of educators, of children, of teachers, of makers, all coming up with really fantastic and interesting stuff. And I encourage you guys all just to have a little look on Twitter later and just see some of the really crazy, fantastic ideas that people are coming up with that are really amazing. And it also involves the hardware. So the microbit, the hardware that you'll have seen, is a very important part of the ecosystem. But it's only one part of the ecosystem. And the reason why microbit is proving so strong around the world is because we have all the different angles addressed, all the learning materials, the communities, and so on. So we are getting big, and we are reaching a global audience. But the question that we're always asked is, how successful is microbit, or how can you prove the success of microbit? And it's very difficult when what you're targeting is long-term educational outcomes. To try and measure the success in the short term is difficult. But as you'll see on the next slide, there is a growing body of evidence that proves what we all believe and what individual teachers have seen for themselves. Now, the BBC conducting an ongoing longitudinal quantitative research survey looking at the effectiveness of microbit, and they're releasing results on an ongoing basis as these results become available. And I've just picked out two of these results just to share with you now, just before I finish. And the evidence that's coming in is that on the next slide, 70% increase in the number of girls that said they would definitely choose computing, and an 87% of kids that experienced microbit claimed that they found computing more interesting having done so. And there's a lot more results like that coming out. But I think the reality is that if you take the microbit into your classroom, you work with your kids, you'll see this for yourself, and you won't need any statistical results to tell you what you can see happening in front of you. But my very last note before I hand over is just to say thank you to all of you. Because what really makes microbit a success is that it's reaching children who otherwise wouldn't have got involved with IT. Children who aren't confident enough to buy a Raspberry Pi, or children who wouldn't go out and code on their own. And those are the children we really want to reach. And it's the educators that help us get there. It's the teachers, the parents, the carers. So all of you out there who've taken the time to get involved, to reach out for those microbits, and then to reach out and get involved with this forum, thank you very much, because as I said, the success of microbit rests in your hands, and we really appreciate everything you've done for us. So that's me. Thank you very much.
Thank you, Philip. And that's quite a mission that you're giving to us. So I'm going to hand it over to Lisa Floyd, who works with us at Fairchance Learning, to see if she can help you, empower you with your mission of getting the microbits into the hands of our students and helping them with their computational thinking and their coding skills so they're prepared for the future.
Awesome. Thank you, Martha. Can you hear me okay?
We sure can.
Okay, awesome. So what a pleasure it is for me to follow Tanya and Philip. And thank you, Martha, for hosting. So I'm just going to get right into things here. You heard a little bit about microbit already, and I talk a lot about how it's really pedagogy over technology, and I've said it a few times at workshops and when I'm presenting. There's something about the microbit that I just absolutely love, and although I really believe that it's pedagogy over technology, this is a pretty freaking awesome tool. So I'm super excited about microbit and the fact that we get to provide training for it. So really the microbit is anything you want it to be. In fact, here's a picture of students testing out the humidity level using a sensor, attaching it to the microbit. When it's a good humidity level, you'll get a happy face, and when it's humidity level that's not so good, you get a sad face. So you can see some science connections there. Then we've got a pedometer here, so you can code a step counter and attach it to your ankle, and for just a few dollars, you have yourself a step counter and a little bit of coding knowledge as well. So you've got those connections to phys ed class there. What we've seen with research and watching people use the microbit is that when students realize they can program, they have the power to program something, it's really exciting for them. And although coding is pretty awesome, the research shows that when students and teachers too are using digital tangibles like the microbit device, they're even more engaged in their learning than with solely coding. My slide's still up there?
We're good.
Okay, because I'm watching on my one computer and I don't see them, so I just thought I'd make sure. So on the Seymour Papert, the great Seymour Papert, if you haven't read Mindstorms, you certainly should if you're interested in the math and coding and other subjects as well. But what Seymour Papert would describe this sort of tool as being objects to think with. And we've heard the term computational thinking, and it's so important for us that we're focusing on the thinking aspect for our students. But then Caffey and Burke, who have written a book called Connected Code, talk about computational participation, so bringing it up a level, and these objects become objects to share with. So students are finding they're so excited about what they're creating that they're creating it for a greater purpose and sharing it with others. Now, what's so wonderful about the microbit is that it has that lower floor that a lot of other devices like the Raspberry Pi and Arduino, I love those devices, but they don't really have that low floor for multiple levels of readiness that the microbit does. It allows for a large range of abilities. And then we've also got the high ceiling, so we can challenge our students so easily with the microbit. Challenging and easily, I'm not sure if those should be combined in the same sentence, but what I mean is that students can use text-based coding to program the microbit, and they can also attach a variety of sensors, and it really is only limited by their imagination. It's also got these wide walls, so we're reaching a wide area of interests of our students. In that, Dr. Resnick, one of the developers of Scratch, the lead developer, talks a lot about how coding provides that wide walls for us, and that students can make anything that they're interested in. And then Dr. Gatanides out of Western University talks about wide walls, giving students the opportunity to share for a wider audience, going outside of the classroom walls and sharing with others. Well, Caffey and Burke would also say that we have an opportunity here to use coding as a new literacy to reshape schools' use of computers to be more creative and more collaborative. So with the microbit, I believe that that's giving us that opportunity to be even more creative than what we've been able to do so far in the past with computers. Also, what we've seen with the microbit is that it allows for more cross-curricular connections. We've already seen this with the humidity checker that I showed you in the step counter. So it really is an awesome tool for making STEM or integrating STEM across all subject areas. So if you look at your microbit, you'll see that it has two programmable buttons, button A and button B. You can hold them both down, or it also has the input-output ports at the bottom, so you can attach a number of sensors. You might attach a humidity sensor, or perhaps a temperature sensor or light sensor, and then you can also attach output devices such as a speaker, so you can program your microbit to make music. So now we've got on the back of the microbit, you can see that it has an accelerometer built into the device, so it knows when you're shaking it. It also has the compass, so students can program a little compass that will display, north, south, east, west, all kinds of different options there. And we've got the Bluetooth, so the Bluetooth allows for the microbits to talk with one another, and also you can program it from your tablet or your phone. There's a few other features as well about the microbit that you can look up. But I'd like to share with you now a little tutorial here. So we're going to program your microbit using makecode.com. So you have a choice here. Either you can follow along on your screen by splitting it, or on another device perhaps, or you could go ahead and go to makecode.com and follow the tutorial that I will go through with you. So again, makecode.com, if I'll get someone to type it in the window for me, and then I will continue on with makecode.com. So once you're on the makecode.com website, give everyone a moment since I can't see the chat window on here. Makecode.com, once you're on the website, you will see that you can go to the microbit on the left here. And there are a number of other devices that Microsoft has supported. So Microsoft gives us this tool for free to code, or this platform to code the microbit. And then you're going to click on the code for microbit so that we're going to get into the coding platform. And we're going to start by coding an animation. So I'm going to exit out of my slideshow here so I can do this along with you. It's a little bit easier to follow along when we do it together. So I'll just get another one. Sorry, there we go. Makecode.com is where we're going. Code. So it might be a little bit delayed while I'm going to it, but hopefully this gives you enough time to explore the coding environment. So you will see, if you have other code on your screen already, what you can do is just click and drag it over. So you'll probably start off with the forever and the start block. And what we can do, so I'm going to keep the forever block on your page. That's what you should see now. And the other one, so the start block, if you had this one up at the beginning, we can just delete it by clicking and dragging it over to the garbage can. You can see the garbage can appears when you go to code it. So we're going to be making an animation now. And what we'll do is we'll make a heart beating, because that's kind of fun. Now, if you look on the categories here, you'll see a number of what I kind of call, or I've heard people call them drawers, and each drawer has a certain category of blocks that you will click on or use. And within each category, each category is color-coded. So if you see a blue block, you know that you need to go into the basic category because it's blue. So what we're going to do is get the show icon block from the basic category. So under basic, select show icon and throw it under the forever right there. So you should be able to see it. And then we're going to grab another show icon block and put it beneath. So you should have two show icon blocks. So on the first one, you're going to have it be a nice big heart, which is already selected for you. And then on the second one, we're going to have a small heart. So you should be able to select your animations by clicking on the pull-down menu. And you will see in the simulator that it actually will display what you just coded. So it's going to be forever looping the two different animations. So right now it's going pretty quickly. It's a pretty fast heartbeat. And what we're going to do is make it so that it does more of a lub-dub sound. So if you're familiar with the heart, you know that it does have a lub-dub sound. And,
so Lisa, while you're doing that, I just want to remind everybody that there's the chat window that you can use if you have questions for us. And also if you want to post your thoughts and ideas to #FCLEDU, that you can do that as a way to stay connected with both Fair Chance Learning, Code.org, and the Microbit Education Foundation after the webinar. And while that is loading up as well, Lisa, I just wanted you to know that in the chat window I said, how cool is it that you're using the forever block to make a beating heart? So romantic.
It is, isn't it?
Anyways, back to you.
Okay, so is it loaded there, Martha?
We are good. Yep.
Okay. All right, perfect. So you've got your forever, and yes, it is kind of romantic. We've got the show icon in the pull-down menu. You've got the large heart and the smaller heart, and it will be a little bit delayed probably for you, the animation, but if you were to do this for yourself, and you can actually do this later because you'll watch the recording of this, and we'll also provide you with the slides, and I have images of all of this on the slides. So we're going to make it so our heart does more of a lub-dub sound. So you can see that I went to basic, and under basic I grabbed the pause. So we're just making a really simple program here just to get you started and comfortable with the coding platform. So we've got the pause block, and I changed it to 50 microseconds. Then I'm going to make the other pause block be 400. I mean, you can decide what you believe the lub-dub sounds like. And then it's going to reload in a second. And on your own screens, you might notice that it does a big heart and a small heart, more like the lub-dub. And so what you might know, if you, of course, having a biology degree, I always like to talk a little bit about the biology. So you can actually talk to your students about systole and diastole. So when you, in between here, the first one, the big heart, and the little heart. In between those two would be the systole, and then between the little heart, and then at the bottom you've got the 400 microseconds. That would be the between the dub and the lub would be the diastole. So you could have your students code a heartbeat and get approximately the right length of time for systole and diastole. So as the heart, as you might know, also it's making that sound because of the way the valves are opening and closing. Okay, so we're going to move on now, but before we do, I was hoping that you could post for us. Let's see if I can switch to my screen for a moment, or my slides. I was hoping that you could post, if you're doing this along with us, with the hashtag FCLEDU. You have a choice, if you don't mind, posting a picture or video of your animation if you were managing to stay on there, or you could tell us how you feel about the microbit so far. If you have a moment to do that for us. Okay. So what we're going to do now is explore some of the other options with the microbit. And again, you'll be able to see all this later, and you'll also have access to these slides so that if it's difficult to follow along with the split screen, you can watch this afterwards or look at the slides. So we're going to use the on button A press now. So what you'll do when you're in the coding environment is go to input. So I'll do this with you. So I'm going to just delete my heart code, my lub dub sound. It's still sort of there. Don't worry, Martha. Okay, so under input, we're going to get the on button A pressed. Now, when you're doing this with your students, if you want to display something on your screen, you want it to be a bit bigger, on the bottom right, you can see that you can zoom in quite easily to your code. You can make it bigger and smaller with a little plus and minus. So we're going to show a string. And a string is like a series of characters. So string is a coding word, a series of characters. And we're going to grab the show string block. And I'm going to just type in hi on there. And then I'm going to put a pause in between. So you can see I'm grabbing the pause block. And I'm going to change the pause to 500. And because it's in microseconds, 500 would be half of a second. We talked a little bit about ratios there, proportional reasoning. Then we're going to grab another show string block. And I'm going to give a shout out to Martha, who is hosting our webinar today. So I've got show string hi, and then when I click on the simulator, you can see that you can click on the A and the simulator. And what's so awesome about this is if you don't happen to have microbits yet, then rather than downloading it, and I will talk a little bit about how to download the program and then upload it onto your microbit, but you can use the simulator in the meantime. And if you only have a couple of microbits for your class, you can have your students code it on the virtual microbit like I am doing now, or on the simulator, and then when they get their hands on the microbit, the physical microbit, they can upload their own code to the microbit just to see what it looks like. So there's our little message, my shout out to Martha. And you can see the words are scrolling across the screen. It might be a little bit delayed on yours, but hopefully you can see that on your own, or on mine rather, but hopefully you can see it on your own. So we have one more program to try to code, and then I'll give you a couple challenges. So this one you might want to sit back and just watch and learn as you go, and then on another time try it again yourself. So it's totally up to you what you'd like to do. So I'm going to start it again. I'm going to delete my code. Now you can save it, so you would just type on the bottom here. I could write message to label my program, and then you would click on the save icon. And then once you click on the save icon, you can save the file and then open it later. So you could save it in whatever folder you want to on your computer for later. So I'm going to start a new project. So I'll go to Projects, New Project. And you can see I'm at the start again. So I'm going to delete the two blocks that I had before because I'm not going to use them for this program. I'm going to be making a coin flipper now. So I'm going to make my microbit do a little bit of a probability exercise. So what you're going to do is under input, we're going to make it so when you shake your microbit, it's going to display either H for heads or T for tails. Now, in order to do this, we have to generate a random number so that the microbit will randomly pick whether it's going to display an H or a T. So under variables, you're going to go to, so variables is like this dark red. So under variables, you're going to click on make a variable, and I'm going to call it flip number. And then I'll click on OK. So I went to variables, make a variable, and then I called it flip number. You can call it whatever you see fit there. Okay, so now what I'm going to do is grab the set block. So you can see the set block is also under variables, and I'm going to put it at the top of my code. Now, if you see any of your code grayed out like that, that means that it's not part of the code and will not be executed. So you want to make sure that it's in full color so that you can see it there. So I'm going to go to the pull down menu and grab my flip number variable, and I'm going to set it equal to a variable or a number between 0 and 1. So it's either going to be 0 or 1. And to do that, you just click on math, so the purple, math. Great, because math is one of my favorite subjects, and so is purple. So there we go. We've got pick random number between 0 and 1. So the number that it will generate is going to be 0 and 1 every time we shake that microbit. So we've got a little bit of math in here. We are then going to need to go to logic, and we're going to use a selection. So we're going to use if, then, else. So make sure you grab the if, then, else. Okay, so it's the one that I have highlighted here. Hopefully that's coming up for you. So if, then, else is under logic. So we're going to add some logic to our program, and I'm going to just snap that in. Notice that once it's highlighted, that's when you snap it in. It just snaps together like a puzzle piece, much like scratch coding for those of you who've done scratch coding. So now I'm going to need some more logic. So what I'm going to say is if the random number is equal to 0, then I would like to display a heads, or H for heads, if its random number is 1. So otherwise, if it's not 0, it's going to be 1, and we'll display the capital letter T for tails. So what you need to do is go to logic, and we're going to grab a comparison operator. So here we have the equal sign. Make sure you're going to logic and grabbing this equal sign, because the maths equal sign is different. We want the comparison operator. So make sure you have the right color. And I'm going to snap the block in. Now, if you approach it from the left side, it won't snap in. You must approach it from the right side and let go. See how I did this? I'll show you again. I approach it from the right side, and then I let go. What I'm going to do is under variables, I'm going to grab my flip number variable, and I'm going to click it in to the first spot. So you can see that I'm putting it into the first spot there. And now it will say if the flip number variable value is equal to 0, so the 0 is already there for you, so you can leave it, then I want it to display the letter H for heads. So what you would do here is go under basic, and I'm going to use the show LEDs block. There we go. And I'm going to check off all the LEDs that would make the capital letter H. So you can see right now that if the number is equal to 0, it will display an H. Else is like otherwise. So if it's not 0, then it's going to be 1. If it's not heads, then you know it must be tails. So we don't have to do another condition. We can just display the letter T. So you go to basic again, and you'll grab the show LEDs, and then drag it to the bottom under else. Now I'm going to make my code a little smaller so you can see all of it on my screen here. And I'll change that to a T by checking off all the LEDs that I want to display. All right, so LEDs. Now we can shake that thing, and to virtually shake it, you just have to click on the little shake, because we can't physically shake our computer, but if it was plugged in, or if we had this on the microbit, that would work. So I always think it's funny when I see the letters LED, because I say the word LED instead by accident. So when the LED lights first came out, I still remember my husband out on the roof and in his running shoes in the winter putting out our Christmas lights, and me saying, "What are you doing right now with just your running shoes on the roof?" And I ran downstairs and got the video camera because I thought he might fall off the roof, and I thought I should record this at least. And I remember saying, "Are those new LED lights that we have?" And so it's on video, me calling them LED lights. So I will forever remember that they're LEDs, but sometimes when I see it in lowercase like that, I still go to say the word LED. Okay, so hopefully you've got all your code done, and you can see that when I shake it, it should be either an H or a T, and it will be random, so we're not really sure, what it's going to be. So I'm just going to check if there are any questions. I assume that I will hear from everyone if there are. I'll just go back for a second. Okay, so we're good there. All right. I love the puns. Okay. So now that you've got your code for that, we're going to add a little challenge here for you. So we're going to add a couple of variables to keep track of the number of heads and keep track of the number of tails. And to do that, we need to create a few variables. So I'm going to, there's a lot of stuff here, go to variables, and I'm going to make a new variable. So hopefully you remember how to do that. Variables, make a variable, and we're going to call it head. Click on OK. So variable, make a variable, and call it heads. We're going to make another variable. So variables, make a variable, and call this one tails. Click on OK. So what we'll do now is we're going to make it so when the user presses button A, the microbit will display the number of heads that have been shaped, so the number of heads that the microbit has displayed. And so we're going to go to input and grab the on button A pressed, bigger so you can see. And what I'm going to do is show a string. So under basic, we're going to grab 2 blocks from basic here. So we're going to grab the show string block. Actually, I guess we need 3, so we might as well bring them all out now. So under basic, we're going to grab the show string, show number, and I'm going to grab one more. I'm going to grab the show LEDs so that I can clear it before I display the number of heads. So we'll get rid of the previous roll, which was either an H or a T, and then it will display a little string for us. So hopefully you've followed along. We've got the show LEDs, the show string, and I'm going to just put a little H and a dash to indicate on the microbit that these are the number of heads, so that the user knows when they click button A, it is displaying the number of heads. The number that you will display is the number of heads. In order to keep track of the number of heads, we have to add some more to our previous code here. So what we're going to do is go to variables, and we're going to change an item by 1. And every time the 0 is displayed, or sorry, the 0 is generated, we not only want to display the H in the LEDs, but you want to go to variables, grab that change block, change it to heads. So variables, change block, change it to heads, and we want to increase it by 1. So each time an H is displayed, we will keep track of that in the variables called heads, and so heads will be increased by 1. So now that we've added that to our code, so I'm going to shake it a few more times. So now the variable heads has as many heads as I have just generated there. And now I would like to display that when I click button A. Right now it's just displaying a 0. We want to display the variable value. So in order to do that, you will go to variables, grab the heads block, which is under variables. Now notice again And just a reminder, you have to approach it from the right because you'll find it a little tricky, and students will too at first. It takes just a couple minutes to get used to that. So you have to click it in from the right. So now, when I shake my microbit, and then I click on button A, it will say H dash the number of heads that we've generated. So we've had 5 heads so far since I made that, since I started counting the number of heads. So you would do the same thing now for button B. So what you can do then is repeat all of those steps, but for button B. So I'll do that a little bit quicker this time. So I'm going to go to button B. Of course, I can't see your screens at home, so I'm not sure where you're at, but feel free to ask a question. And again, you'll be able to pause and play this as much as you want later because it is being recorded. So under on button B pressed, we are going to add the following. So notice what I grabbed the button A block, but I had to change it to button B. So now I'm going to add some code. We're going to add the same code. Now you have 2 options here. You can go under the drawers and grab the code, or a little trick here is to right-click and duplicate blocks. Right-click and duplicate blocks. And I'm going to do the same thing for all of them. Duplicating my blocks. So now what I need to do is we need to create, or we have our other variable made, but we need to make sure that when a tail is generated, or the random number 1 is generated, that we increase the tails variable by 1. So we're going to go to variables, and we'll change it. So variables is the dark red, and we're going to change. So under variables, change our tails variable by 1. So we've got tails by 1. And then we'll need to go to our button B and adjust that. So you can just click on the pull-down menu and change your code. And notice I have that blank set of LEDs so that between. So you'll notice that I'm walking you through like a pretty scripted, like I'm doing step-by-step algorithm on how to make an algorithm to make your microbit display either a H or a T. So once you've done that with your students, or that, they might go through a step-by-step instruction or tutorial, it's really important that you then have them, you challenge them with something else afterward. And that's where the real thinking comes in, is when the students have to adjust their program to make something else. And also not just the thinking, but the creativity or the creative thinking happens when they have to create something else based on what they've learned. And of course, they'll take it way up to another level, and they'll teach you, the teacher, how to do a lot of things. So we've got our heads now counted, and we've got our tails counted. So a really cool thing would be to then make it so button A and B, when you press button A and B at the same time, that it will actually display the total of flips. So what I'm going to do is I'm going to go through this. It's going to take a little bit, but I think it's worth it so that you can see that you can do some math. You can add up things. So we're going to do some mathematics here and add up the number of heads that have been rolled and the number of tails, so we know the total number of flips. So what I would do then, or what you can do, is go to Input, and we're going to grab the button A again. So when button A is pressed, and I'm going to move, you can see I can move my screen over so that we can focus in on the button A, B. So you'll scroll down or click on the pull-down menu and select A plus B, so that when you hold down both A and B button on your microbit, this stuff will be displayed. So we're going to grab the same thing as we did before. We need to go to Basic, grab the Show LEDs, right here. Basic, Show LEDs. And then going to go to Basic and show a string. Type in total. Just about done here. This program, so total dash. And then you can go ahead and add them up. So what we need to do is make another variable, and we're going to call it total flips. So I went to variables, make a variable. We'll call that total flip. Now, in a lot programming languages, variables need to be all one word, so I tend to be in that habit, but I'm just going to write it like that. So total flips, and then click on OK. So now we have a variable that's going to hold the total flips. So what we have to do is add up the heads and the tails. So before that, we need to stay under variables. So under variables, you're going to grab the set block. So I went to variables, set block. Variable set block, under the pull-down menu, we'll change it to total flips. And we're going to set it equal to something. What we're going to set it equal to is the heads and the tails added up together. So here's where you can go to math. And it used to say maths there because it was developed in England. So what we're going to do is grab the plus. So under math, grab the plus operator, and you can snap it inside. Notice again, you have to approach it from the right. And you could change the operators here, but we want to use the addition operator. And here's where you go back to variables. So I went to math, and I grabbed the plus operator at the top. Now I'm going back to variables. And we will grab the heads. So I grabbed the heads block from variables, and now I'm grabbing the tails block from variables. So now, once you have all that code done, you can test it out. Notice that when I added the new button A plus B, it made it so in my simulator, you can test that out, because on the virtual microbit, you don't actually have the A and B. You can't physically press both at the same time, but on the real one you can. So I'm going to click on that. So right now it's going to say total, and it will display the total and dash, because that's what I have in my code, and then however many total flips we have. Give it a value. Okay, so what I'm going to do is I'm going to shake it a few times. There we go. Check our heads, make sure we got everything, and our tails. Oops, slow there. There we go. It's a little delayed, so I clicked on it a few times, so it's going to give us our heads total. There we go. It's probably difficult for you to read on my screen, but that should all work for you. So we've got our total flips is equal to, oh, I know, I didn't actually display it. I just noticed that. I was thinking, where is it? So we showed the number on the other two, and I'm sure that those following along we're yelling at their computer, show the number. So there's one line of code missing there. So we want to make sure that under basic, show number. There we go. And your students will make lots of mistakes like that. I make loads of errors, but the whole beauty about programming is that when we have a bug, we don't panic. Well, maybe when you're doing a live webinar, you might, but you would be kind of excited by it because you have a challenge for yourself. So I'm going to go to show number and grab the total flips there. So now when I display the A plus B, oops, we'll let it catch up there, it will say the word total and then the dash, and then it will display the number of flips. Oh, 0 right now. Okay, so we'll keep shaking because it reset there. Shake it away, and then you can test it out. Now, what you could do with your students is, some will be done faster than others, depending on if you're doing it as a class or if they're following along a tutorial. And you could say, okay, can you make this a weighted coin? And they will figure out a way to make it so that it will be like a weighted coin. And then what they could do is they could share their microbits with each other, and the students can figure out what they've done to make it weighted, or they could figure out what the ratio of heads to tails was. They could just shake it a whole bunch of times, and then they could keep track of that, keep track of the data, put it in a spreadsheet or just put it on paper, and then at the end, the microbit is actually recording the total for you, but at the end they could figure out that maybe they made 3 random numbers and 2 of them were heads. So that's one way that you can do that. So I'm just going to show you my slides and show you a couple other things that you can do, and then, or just to inspire you to try some other stuff. So I'm going to go back to my slides here, and I'll scroll through. Here we So yes, again, the weighted coin is a really neat idea to challenge your students, for sure. And then the next challenge I would do is once they've learned how to make heads or tails, you could then say to them, okay, can you go and make a rock, paper, scissors program? So that's what I was talking about, where once they learn the basics of something by following the step-by-step tutorial, I kind of believe it's a good model for them to, it's nice to let them just explore, but to give them a program with a bunch of things that they could learn, and then they can go create their own program, that gives them a little bit more power because they're more skilled. So here we have an example of a rock, paper, scissors program. We're not going to code that right now, but you could do it. So on Shake, I just made a variable between 0 and 2. So the variable would either be 0, 1, or 2. And if a 0 is generated, then I display an R. That's my fancy R. If a 1 is displayed, then it would be a P. Otherwise, the only one left would be a 2, and so I display an S for scissors. Now, to get that second else if, you would click on the tool. So you can see the little tool circle thing. Whoops, I'll just go back here. So this here, I think my cursor is on the screen, but hopefully you can see that there is a little tool there for you to click on, and then you can drag it in. Actually, I'm going to show you that tool because it is a little tricky. So I'm not going to make that program, but I will show you on the program that I have on my screen now. So you will click on this little tool. I'll have to make my code smaller. It might be a little difficult for you to see. There we go. So you click on the tool, and you'll see something will pop up. So this is a little tricky for some people. So what you'll do is you'll grab the else if and drag it onto the little box. So you see there's a box on your screen, hopefully. So again, if you want to add some else if, so if you want to add more conditions, you just click on the little else if and drag it over. So now I've got a few else ifs. So for my code for the rock, paper, scissors program, what I had to do there is I had to add a second else if, and then the rest of the program they should be able to create that, and so should you now that you know how to make a coin flipper. So I'm going to go to my next slide now. A wonderful task as well, now that they've learned all those tools, they should be able to make a dice roller. So you can turn your microbit into a dice roller. And you'll see each of your students will probably do it slightly different. There is a more efficient way to do it with only about 4 blocks, but I'll leave that as a challenge for you to try sometime. But you can do it along the way with a whole bunch of else ifs. Okay? So what's wonderful about this is every student will have a different program on their screen, or slightly different, especially when you get into more complicated programs. And the math teacher in me is excited about that because you want to promote math discussion whenever you can. It's the same when you're talking about your programs. There's some real deep thinking that's going on, and you will notice that when your students start comparing their programs. So a really fun program that students like to do with all of it. So again, this is a program that you can do with all the knowledge that you have learned today, is a Magic 8-Ball. So you can see that's using the same concepts. We're using variables, we're using selection, we're using inputs, we've got the shake, a random number between 0 and 7, so that's 8 different values. And then you can see I just had to add a whole bunch of else ifs, and I have the first couple done for you. So if my magic 8 value is equal to 0, when I shake that microbit, I'll ask it a question like, is it going to rain today? And on a day like this in London, Ontario, at least, it would say definitely. And then as you go down, you'd have maybe 4 yes positive answers and 4 negative answers, and the students can play around with their Magic 8 ball. So that's a little idea that you can do with everything that we've learned so far. So just a bit about how to download your program to the microbit. It always takes a little bit when you do it with your students for the first time, and with teachers when we do it at workshops. But once everyone figures out how to do it on their computer in whatever web browser they're using, then they're good to go. So it does take a little bit. So if you're using, I think this is Explorer, but here's an example of what to do. So you have to understand, I'll put all that up so you can kind of read it if you want to. When you plug your microbit in, there's a little cord that it comes with. When you plug it into your computer, your microbit is just like a little USB key. And so it will open up, it'll automatically, on the left-hand side when you go under File Management, you'll see that, I'm putting up my screen as if you can see me pointing, that microbit folder. So what you'll do is you'll click on the download button that you saw on my screen on the bottom left of your makecode.com platform. You'll click on that download button, and then it might come up something like this that you see on my screen, or it will just download it. In some cases, it'll be on the top right, and you have to click on the little arrow, or in some cases, it'll be on the bottom left, and you have to click on the little pull down. But what you want to do is not open the file. You want to open the folder that the file is saved in. So this is just basic file management. So it does take a little bit for everybody the first time, especially when everyone's on a different device. So you do have to keep that in mind. So you can see that it's show in folder that we do. And so once you go into the folder, you will see where your hex file, it's an HEX file, is saved. And if you've named it, you'll see the actual name of your file. So where I showed you, you could name it. And then what you'll do is you'll click and drag it into the microbit folder on the left-hand side. So you'll either click and drag, or you right-click, copy the file over to your microbit. So it's just like a USB. It's just transferring a file over. And again, the first time it will take a few tries, and you'll have to run around the classroom helping everybody. It's great if you can do it with some older students first and bring them in to help you. And then you have a whole bunch of teachers in your room. We're going to click onto the next slide to show you a couple other things. So for resources, there are countless resources, okay, on your on the microbit.org website. So you can see we've got a lot of code editor windows. So you can go to the microbit.org, and you'll have this website on the slides and also on the video if you want to watch it later. And there's a whole bunch of editors. So they've got JavaScript blocks, Python editor, so you can code in Python, which is neat. Microsoft Touch Develop, if you've been using that already, it's kind of neat. Also on the makecode.com website where we were, at the top, you could change your code. The block code that you've created, you can change it to JavaScript really easy. There's just a little button at the top to click on it. And it's kind of neat because some students will be very curious about that and will learn JavaScript just by comparing their code, their block code, to JavaScript, and they'll learn it fairly quickly. So there's the editors. Also on this wonderful website, microbit.org, are a whole bunch of free teaching resources. So the latest is clearly a trend here with Doctor Who, but there's a whole bunch of teaching resources from all different curriculum subjects. And remember, this has been used for over a year now in the UK and Northern Ireland and in some other countries as well. And so what you can do is go to that resources website, and there'll be tons of resources for you to find. And they're really nicely laid out lessons that you can gear towards any of your, whatever province you're living in right now. It will certainly work for you. I'm sure you can make it work. Now this one's a little bit tricky to find, so I put the direct link to it, microbit.co.uk/blocks/lessons. And the reason I've done that is I just like the way this is laid out. It's very quickly. So I've got one of my little ones trying to show me some clay that he's made. Anyway, so we've got the beginner, intermediate, and more advanced programs, and you can click on each of those, and then there's some really fun, simple programs, and they get a little bit more challenging. You can see there's the rock, paper, scissors, or a similar one would be truth or dare. So we'll go on next. So one of my children are asking me for chocolate, and I'm like, yes, just have it. There we go. So that's pretty much all I want to share with you. And of course, if you have any questions, now would be a great time to either tweet them out. I haven't been having a chance over the last few minutes to check that out, but certainly you can hashtag FCLEDU, or you can ask in the window there. So there's if we haven't connected on Twitter, I'd love to do so with you. So I'm going to exit out of there.
Can I, Lisa? Do you mind if I just shout in briefly?
I'd love for you to.
That was a super workshop. Thank you. In terms of URLs, I'm not sure if you guys can see my chat window, because I can't see your chat window, which is really upsetting. But the .co.uk website is the old one that the BBC looked after while they were running the program. What we've done, the foundation has taken over the website, and we've migrated it over to microbit.org, which was a lot of the screen grabs, but there were a few URLs that just had .co.uk, so I'm not even sure if you can get that outside the UK, but as I say, just ideally go to the .org website, and everything there is brand new and up to date and everything.
Thanks, Philip, and I'll just let you know that in the chat window it said that Philip is amazing We think he's wonderful for joining us so late in the evening. That's the sentiment from the chat window. So
thanks, guys. It's an absolute pleasure.
You're not missing anything except wonderful comments for both you and Tanya there, Philip.
Thank you.
And so, yes, just to reiterate what Philip said there, microbit.org can get you connected to all of those lessons and activities. MakeCode.com is also a great platform to get started with your microbit. And then, as Lisa said, if there's anything that we can do here at Fair Chance Learning, we're more than thrilled to support you in your journey as you embark on computational thinking, coding, and connecting it to your students' creativity and inspiration that will come from that. So if there are not any questions, I will stop the recording now, and if there are questions, we can stay on for a couple more minutes to address those questions. But again, this doesn't stop here. This is a journey over the next who knows how long, who knows where we'll go from here with microbit and code and Fair Chance Learning. But rest assured that if you're staying connected with us, that we'll give you the up-to-date information and the best support that we can possibly give you, because we absolutely believe that every student deserves a fair chance in learning, and that's what we're here for. And we're here for those cute students that Lisa has in her office as well. So a big thank you to Lisa and those little boys who did such a great job. And I'm just, it's good timing in my house that there's nobody who's run through the screen here. But a big thank you to Tanya and Philip for coming onto this webinar. We will be posting it, and you can look on our Fair Chance Learning Twitter handle tomorrow night. It will be live once we recorded it. But we do have a number of children who need to be tucked into their nice cozy beds here in Canada. So I'm going to stop the recording, but we will stay on for the next couple of minutes and address any questions that you have.